So yeah, as I mentioned, Automation NTH works primarily in life sciences now. And so the project that I'm going to talk about today was where we actually integrated SCADA with third-party equipment with one of our life science partners. And this particular manufacturer produces high volumes of intraocular lenses, IOLs for use for cataract correction. They're one of the global leaders in sales for these, widely revered by doctors. And the process for making them is pretty high precision and has some pretty strict requirements behind it. And kind of where they were at before they contacted us was they were kind of getting new automation in, some fully automated equipment in. They had some troubles in the past, and they found another integrator that they finally could get some equipment from. But they kind of had this paper-based process for tracking all of their batches. They would kind of create an entire tray of about 96 of these IOLs, and that would be a batch, and they would quite literally rubber band the paper to the tray, and that would ship around as that batch was worked on, and they scan it and print out new pages and put it in the plastic envelope and everything whenever they needed to, and so on and so forth. And so their whole goal was, with this new automation that was coming in, they wanted to eliminate the paper trail, the physical paper trail, but they also wanted to sort of automate some of that ERP interaction as well. So when they would update documentation, or when they would need to scan it and things, or when they were entering the results of whatever process they were on into their ERP system. So they had operators kind of manually doing that on tablets and small computers and things. And it took quite a bit of time to do that. So we have a fairly, semi-manual or semi-automated and manual process for their automation, but then also a completely manual process for their batch tracking throughout pretty much their whole facility. And so with that, there were some kind of challenges that were presented to us to kind of overcome for integrating SCADA. Our SCADA system needed to be 21 CFR Part 11 compliant, since within life sciences this is pretty common. And so we needed a complete audit trail of configuration parameters, anything critical to quality, batch reconciliation, operator actions, among many other things, that come with 21 CFR Part 11 compliance, like security and standard operating procedures and timestamps and so on and so forth. We needed our SCADA system to work with kind of like a hybrid manufacturing environment, where we were going to have fully automated equipment, we were going to have semi-automated equipment, and then we we're going to have like still kind of completely manual processes as well. And so we needed to have things in place to kind of handle both. So we needed some operator interaction. Then we, needed, the machine software to kind of do everything automatically in certain cases. So we needed manual ERP entry in some instances, and some manual intervention in between those automated processes. But then we also needed the automated equipment to actually do those things completely themselves. And then with that, all of the machines that they were ordering, of various different processes that we worked on for this particular site, they were ordering from kind of all over the globe. They were ordering from the US, they were ordering from Spain, from Germany. And so with that, we had to integrate with a lot of different integrators, saw their own code and things, because this particular site doesn't have necessarily a coding standard. And with that, there were also several different controllers that we needed to interact with and things as well. And then we needed to also capture their data, the amount of data that they wanted at the scale that they wanted. So one piece of equipment had a cycle time as low as 0.7 seconds. So every about 1.4 seconds, 2 parts were coming off of that machine. And so, and the level of granularity that they wanted their data was, they wanted it, what machine processed it, what station processed the part, what nest it was in at that station, any process data collected at that station, what operator was running at that time, so on and so forth, even down to what parameters were used and what material was added and things. So it's a very granular data at a fairly quick rate in some instances. And so our kind of strategy to overcome that was, we standardized on using Ignition. And so we knew we wanted to use Ignition and plus SQL Server, since this site particularly standardizes on SQL Server. And so, but we also knew with those two things that between the two of them, they could be fully conformant to 21 CFR Part 11, just kind of inherently with the audit profiles and even the custom audit capability that you can integrate with a lot of features in Ignition. And then same with SQL Server Audit, and then temporal tables and things as well. And then we knew we wanted to use reusable APIs per machine. So obviously, if we have to redo anything or use new code, that means revalidation and things. And so we didn't want to change a lot going from equipment to equipment. So we wanted a standard set of APIs that all the machines would use so we could validate them once be done. Then to overcome the hybrid manufacturing, environment, we came up with an idea of using like an operator kiosk on the floor, so a touchscreen ignition vision application in this case that the operators could use to perform some of those manual tasks. But then it would also give engineers and technicians and things insight into the data analytics that we were collecting with the machines as well. And we also wanted to have a common tag model to go along with those reusable APIs as well. So that way, for some of that live data that we weren't storing all the time, we could actually view that seamlessly within the same screen across all the equipment. And in that common tag model, we kind of also created a very lightweight data handshake. So it's just single tag, UDT that we used for all of those APIs. So it's a single UDT that's used for any database call from there. And so, and by using making it kind of lightweight and really having Ignition only look at the handshaking tags all the time, reduce the amount of like constant OPC traffic to the machines. So that way we'd only need to read the data or write to data, OPC data, whenever it actually performed a transaction, like whenever the part actually left the machine, we could then log all the data or things like that. And then all of that was kind of built on top of scalable physical and data architecture. So scalable physical architecture was we use a scale out approach where we had multiple gateways and databases spread throughout their different clean rooms. And then that all kind of connected back to another gateway that was connected to their IT network. So they had proper IT and OT segregation there. And so they've actually used our tag model and things to kind of build an application on that centralized gateway, whereas most of our applications kind of run on the branches of that. And then that scalable data architecture, that's important too, right? So same with the reusable APIs, we needed a solid foundation for our table structures and data. So that way, whenever we would add new equipment, we don't have to make any changes. We don't want to edit tables in the database and things when we want to store new information. We want to use everything that's already there and just configure some things when we add new equipment. And so, I mentioned we wanted to pick Ignition, but why would we want to pick Ignition? And a lot of these things Paul kind of already talked about. Unlimited licensing is honestly awesome. Ignition's licensing model is second to none, as the best licensing model out of any other SCADA platform as far as cost goes. And their capabilities also go with that too. So it's a win-win. But speaking of capabilities, they're database native, so they can connect to pretty much any SQL database that we need and more as well. And especially in their cloud edition and stuff, they've got some other database connectors and stuff too for that. So talking to any database is important. Security, and I already mentioned the built-in auditability. Those are very important for 21 CFR Part 11 compliance. And then the gateway scalability with the gateway network is extremely powerful. Connecting tags that are being collected from remote gateways and centralizing those into a single gateway through the gateway network is very simple to do and very powerful too. And then just their open integration, just being able to talk to pretty much any device from OPC UA to MQTT, scripting, database queries, serial communications, TCP IP comms. You can pretty much do anything in Ignition, which is pretty awesome in itself. So with all of that, our solution ended up being kind of compliant by design. So we met their 21 CFR Part 11 requirements fairly inherently within the system. We had some customization, but for the most part, it was built on tools within Ignition and SQL Server. And then we had, one model for every machine. We had a common tag model and reusable per machine APIs, similar to a UNS. I wouldn't quite call it a UNS yet, but very similar to that, shared throughout all the Ignition gateways. And so we had a UI that could run all the equipment from a single UI as well. And then we were able to produce that data at scale all the way to the ERP system. So we were able to collect all of that data, allocate it into a database, auto-submit batch records, and really hold all of that data to an extremely high data integrity as well, with very little performance impact to any hardware device on there. I don't think any gateway was running over 5% CPU utilization and RAM was always good, and the PLCs hardly saw any interaction as well with Ignition. So, and then the operator kiosk at the line really was kind of like the final touch to that. So being able to have that analytics insight but then giving the operators the ability to easily perform some of those manual transactions things and just kind of really simplifying that. And so the customer value that we delivered, we delivered faster and more reliable ERP logging. So we either completely eliminated the manual interaction with the ERP system, or we significantly reduced it from the 20 to 30 seconds per batch for an operator to manually enter things. We reduced that to just like 4 or 5 seconds, 2 or 3 clicks, and they were done. So before they were having to like manually, scan the batch or type it in, and then they'd have to select serial numbers that were rejected and select the failure reasons for why they were rejected, and so on and so forth, and then submit all of that and do some manual typing of time and everything. And so all of that is just kind of already collected, and it pops up on a screen, and they just look at it and they say, okay, confirm, done, because we've already captured all of that information. And then by creating electronic records out of these and kind of reducing that paper-based record keeping, we improved traceability of each batch wherever it's out on the floor, but we also made that more easily accessible by centralizing that in a database. But then we also gave it insight into production, access to OEE, alarm data, part and process data, and some of that's kind of in the pictures out to the right, associated with every part. So you can have a complete part birth certificate, of all the information for a product that was collected on it throughout its entire life cycle. And then by implementing that scalable data and hardware architecture, we're able to a plan for future scalability to try to simplify equipment onboarding, so with reusable APIs and common tag models, but then really focusing on more of a configuration based setup where we can just go and edit a couple of tables of information and add a UDT instance in a single UDT instance in Ignition, and boom, you've added a new machine. And then with the scale out architecture, that in itself is inherently scalable from a hardware perspective. So they were very, very happy with this solution, so much so that we're doing work with other sites as well. And so continuing to add that same value to several of their other sites, and with perspective on some of the other ones as well. So, but yeah, I believe that's pretty much it. And if you had any more questions for us or wanted to know more about Automation NTH, you can contact sales at Automation NTH or contact me, John.Mullins at automationnth.com. And yeah, we'll help you solve your problems.